The people here we have on stage are some of the world's leading experts on toilets, whether they want to admit it or not. And if they don't want to admit it, I'm sure it's only out of their sense of modesty, because toilets are an important topic, and I'm glad we're going to get a chance to talk about it today. I'm going to introduce each one of them individually, then I'm going to give you a little background on what we're going to be talking about, and then we'll get into the questions. And given the topic, I'm hoping there's plenty of time for your questions at the end of the discussion, or toward the end of the discussion. I'll start with John Koeller. On my right, John is principal of Koeller Company. He's a leading expert on water-efficient technologies, products, and practices. He is a technical advisor to the California Urban Water Conservation Council and to the International Alliance for Water Efficiency. John is a member of IAPMO's Green Technical Committee, the ASME Standards Committee for Vitreous China plumbing fixtures, and has served as vice chair of the LEED Water Efficiency Technical Advisory Group. John is co-promoter and ongoing developer of the maximum performance test for toilet fixtures, one of the key catalysts that led to improved fixture performance in North America in the last decade, or in this decade. Next to John is his associate, Bill Gawley. Bill is principal of Veritech Consulting, an engineering firm that specializes in advancing water efficiency. Bill has more than 17 years of experience developing municipal water efficiency programs, testing water efficient products, and field testing. Bill's a founding member of the Canadian Water and Wastewater Association's National Water Efficiency Committee, and a technical advisor to the International Alliance for Water Efficiency and the US EPA's WaterSense program. Next is CJ Lagan. CJ has been with American Standard for 15 years in 3 plants in 2 continents, and I just found out the second continent was South America. Currently, he is a compliance engineering manager for fixture products, including American Standard, as well as Porsche, Crane, Fiat, and Elger. CJ is about to graduate with a master's degree in applied statistics to add to his bachelor's degree in ceramic engineering. And next is Rob Zimmerman. Rob is the senior staff engineer for water conservation initiatives at Kohler Company, where he is involved with all aspects of water conservation and sustainability related to plumbing fixtures and faucets. He chairs the WaterSense and Water Efficient Products Committee for the Alliance for Water Efficiency, co-chairs the Water Efficiency and Sustainability Issue Committee for the Plumbing Manufacturers Institute, and is a member of the IAPMO Green Technical Committee. Rob is a LEED accredited professional. Next is John Watson, the Director of Water Efficiency for the Sloan Valve Company, where he leads the water efficiency efforts and monitors other industry activities. 20 years in the plumbing industry prepared John to work in the design and manufacturing of commercial and industrial plumbing products. An active member of ASPE, ASSE, and ASME, he is involved in several work groups that write a variety of product standards, including those related to more water-efficient plumbing products. Fernandez is the Deputy Director, Codes and Standards, Development Engineering for TOTO USA, Americas Division, where he has spent most of his professional career. At TOTO, Fernando has worked on numerous water efficiency projects and has witnessed firsthand how the cyclic movement for more conservative and conscientious approaches toward water usage has affected the industry. And time permitting, Fernando, I'll ask you during questions what exactly that means. But he is a member of several water efficiency advocacy groups and serves as secretary for 2 ASME project teams. Stephanie Tanner is the lead engineer for US EPA's WaterSense program and was introduced yesterday as one of the panelists on the Green Home Builder panel discussion. Today she will share her insights on toilets. I found out yesterday that Stephanie has her degree in marine engineering, which I think is great, but she can apply that to a water-related field, so that's good. Before we get into the questions for our panelists, let me provide some background information. And John, Bill, and Stephanie, please interrupt me if any of this is incorrect. In December of 2003, John Koeller and Bill Gawley published the first edition of the maximum performance of MAP, MAP test for 1.6 gallon per flush toilets. This test, for those who are not familiar with it, requires that increasing amounts of miso paste acting as a simulated solid waste test media be placed in a test toilet along with 24 sheets of paper. Let me pause here to let you know that we'll be using the term media frequently in this discussion. As a member of the media, I want to be clear that we will be referring to the media that you flush down the toilet and not to my chosen profession. Well, anyway, in order to meet the original MAP specification, a toilet was required to flush 250 grams of the miso paste in all of the toilet paper in 4 out of 5 flushes. If successful, the amount of the test media was increased until the toilet failed to flush all of the media. The highest load value passing the test represented the MAP score expressed in grams of that particular toilet model. The test has since evolved. Maximum MAP scores, which were initially unlimited, were capped at 1,000 grams. Most recently, the U.S. EPA essentially adopted the MAP test. John tells me there was another test involved there as well, with a 350-gram pass-fail score only as a performance test for 1.28 gallon per flush or high-efficiency tank-type toilets, the first ever WaterSense specification. Today, the accuracy of ranking toilets remains a hot topic in the plumbing industry, which is why I'm hoping we have time for your questions at the end of our discussion. At this time, our panelists will share their thoughts. I'll be asking them some questions and then some follow-up questions as we have time. Our point is really to share their thoughts on how to improve the current MAP specification and how to best communicate test results. And perhaps that's even a more important consideration to product specifiers and consumers. First up is CJ Lagan. Question for you, CJ. If you could change one thing on the current MAP rating specification, what would that one thing be?
If we could change one thing on the current MAP rating system, and I think we as a company have to say that we have no real bones to pick with the current MAP rating system. But it would be perhaps to add a little bit more maybe data strength, perhaps testing of multiple models. And I have 2 slides that I wanted to show if this question came up.
Okay.
Not that one, the next one.
The next one, please. There we go.
What we would hope that a future MAP test might have, that being American standard, would be analysis like this. It's a very noisy graph, I apologize. But on the horizontal bottom axis, you see the load that was placed into a toilet bowl. Sorry, Bob, the media that was placed into a toilet bowl.
That's all right.
And on the vertical axis, you see the probability of failure. Now, we don't exactly know that. Probability of failure being probability of flushing. We don't exactly know when the toilet's going to fail. If, say, that purple line, I believe, is a 1,000-gram toilet. But we can estimate both empirically by testing and mathematically modeling it so that we can understand if a 1,000-gram toilet can do so well, it's going to perform that good at 350. We're not hypothesizing that 1,000-gram is humanly possible, but we like to understand how it performs, like say, as a quarter-mile test for a car or a skid pad test for a car. You're never going to do either of those 2 things, but we want to see how it performs there. And we're just trying to model a chaotic event and trying to provide some structure to that chaotic event. And the use of multiple samples. We politely suggest that maybe more than one is better, perhaps 3.
Are you talking about more than just miso, in other words?
Oh no, more than one toilet.
More than one toilet, okay.
Yeah, if you collect if you have a 1,000-gram toilet and you put it on a shelf, if you come back 2 years later, the one that it's identical to, its twin, might not flush 1,000 gram. It might be over, it might be under, but it probably won't be exactly 1,000 if you can measure that good. And we would propose that measuring 3 samples would be a little bit surer.